Okay, and so let's go on with some of the questions people asked, okay? And we'll see how we answer them, okay? Let's see where they fail in their criticisms, okay? Let's see what they don't know, see if they have any valid arguments. Here we go. First one says, contraction is quite literally, I talked about contracting, special relativity says that if you travel at the speed of light, you contract in the direction of motion. Okay, that's what this is about. That's the context here. Contraction is quite literally having one of the dimensions an object occupies disproportionately decreased. Okay, we could go through the rest of it. Not important, really. We can go on the last one there. Then you can perfectly say that its length was contracted. Yeah, the problem is length is a concept. We do not contract concepts, okay, and that's where the problem is. So here we go. Here's an answer to this fellow. It says, in physics, you can see that the ruler contracted, not that length contracted. That's language of religion. That's the mathematical physics with quotations there. Mathematics way of speaking. They say the length contracted because they're talking about a measurement. They're saying it was 10 meters, now it's 9 meters. That's why you talk about contraction of the length, because they're referring to the numbers, okay? And no, in science, portion, part, segment, region, length, dimension, none of those can contract because none of those are things. You can't say that east to west contracted, the direction east-west. You can say that the object contracted in its east-west direction. And all words in the dictionary can be divided into objects and concepts, okay? And you cannot use physical words or verbs and apply them to concepts. You cannot say that a concept contracted, became bigger or smaller or larger or heavier. You cannot say that about a concept. Okay? That only applies to objects. What is an object? It's that which has shape. You can talk about anything related to that shape. Concept, that which doesn't. But, so you can distinguish that. That's a rule of thumb. When you go through the dictionary, any word you look at, does that word represent something that has shape, or does it represent that which does not have shape? And that's how you decide real quickly if it's an object or a concept. The definition of concept, the formal one, is a word that invokes or embodies two objects. In other words, you need to define the word object before you define the word concept. And a concept is simply a relation that a human, establishes between two objects, usually a human. And there you have synonyms, relation, and contrast. That's essentially what we're saying, okay, when we look at concepts. Okay, so we need to define what a concept is, otherwise we cannot talk intelligently. And if you have other categories other than object or concept, hey, bring it on. You want to see how they differ from the object-concept duality or dichotomy. Okay, here's St. Paul says, your attempt at defining the word definition completely failed. Oh, I'm so sorry. It failed at the exact moment where you said definition is defined. His argument is going to be that we're using the word definition to define the word definition. So it's he says people like him have this notion that there's no word you can define, because as soon as you put a string of words to define that word, now you have to define each one of those. And the words that you use to define each one of those, now you have to define each one of those, and so on ad infinitum. And so he says, hence the word definition failed to be defined and cannot be defined. Okay. Well, yeah, he's playing around with nonsense there. It's they call themselves sometimes philosophers or linguists or whatever they do, and they think they're great scientists. But here it is. In science, we must define the word definition. We need to know what the word definition is. The doors of this conference room are locked. No one can get out. There's 8 billion people inside this conference room. And nobody can get out until we define the word definition for the purposes of science, okay? We can't play around with this, like this fellow says, oh, you need to define definition before you define definition, and so on down the line. That's these people who chase their tails around. They've been doing so for 10,000 years. We don't follow any of that. We do it the down-to-earth way. Definition, a limitation placed on the extent or usage of a word. That's the definition of definition, according to science. If you don't like that definition, you have a better one, a better mousetrap, hey, bring it on. What we want to see is your definition of definition. If you say you can't define it, well, you can't leave the room, not even to go to the bathroom, because there's 8 billion people in this conference room, and we need to define that word. Another word we need to define is the word object. Can't do physics without objects. Imagine there was nothing out there, absolutely nothing, whatever nothing is, okay? You have absolutely nothing. God erases every atom from the universe, except himself, hopefully. You know, he's a spirit, I guess. And so what's happening? You know, what's going on? What's taking place? What's colliding? What's expanding? What's, weighing down on or causing gravity or whatever, if you have no objects? So the first word that you need to define in science, in physics, is the word object. You need to know what a thing is. And no one, especially these people like this fellow, no one has done that in the last 10,000 years. No one can define the word object. No one has defined it. And more important than that, no one has realized the importance of defining the word object for the purposes of physics. And we're going to deal with that a little later when we find out what physics is about today, right? And here, this is what this poor fellow says. He says, your claim that objects don't need to be defined. We just have to point to them with our hand. But for that to be true, we would first need to know what hand is. Aha. Okay, you cannot point to it since you are using hand to define what a hand is. Okay, and he continues on with that. Essentially, idiots like him. An idiot, by the way, is an individual with big ideas. You know, it's not a little idea; it's an idiot. And so these idiots, right? They go around and chase their tail around forever. And so the first thing you have to realize that you don't need to define the word hand. In fact, the Klingon can come to Earth, right? And what happens? He comes here and he says, he brings a box, right? He puts it on the floor. And he just says, what do you call that? And you look at it and say, we call it, here on Earth, we call it box in English language. And so he says, and what do you call that? Well, that's tree. And he points, so you don't have to point at, if you don't know what your hand is or where your hands are, you don't have to point, okay? Don't worry about it. He'll do it for you, okay? So you don't have to know what a hand is, you know. You just look at what he's pointing, using to point. Maybe he uses a stick. I don't know, maybe he doesn't use his hand. Maybe he points with his nose. I mean, and so he said, what's that? With his nose. And he said, and you say, that's a house. What's that? That's a tree, and that's a rock, and so on. You teach them your nouns, your things, okay? You teach them the names of the things, okay? That's what we're talking about. And that's how you present an object in physics, okay? We do not need to know what a hand is. But yeah, I guess poor fellow, he probably has mental problems. That's what I'm suspecting, okay? Okay, he continues, says, Wittgenstein's thoughts. Wittgenstein's thought. Wittgenstein was, Ludwig Wittgenstein was a so-called, they call themselves philosophers. None of these guys were philosophers. There hasn't been philosophers in all of history because no one defined the word philosophy. So no one knows what a philosopher is. What is it? Love of wisdom? What is that? You know, you have to define the word philosophy. So when you go to the university and say, I took philosophy, we know what you did. But if you say, I'm a philosopher, I took philosophy in school and college, whatever, you say, oh, what is a philosopher? Well, it's a guy who loves wisdom, whatever that is. And yeah, the Stanford Encyclopedia of Philosophy does not define the only word they should have defined, which is the word philosophy. So we don't know what Stanford Encyclopedia of Philosophy is. Okay, so Wittgenstein's thoughts about it being nothing are contradictory. Because the term nothing cannot really be defined. He says you can't define nothing. Okay, let's find out why. If we remain strict to the notion it is trying to refer to, we would be, which would be absence of things. No, that's not what the notion of nothing is. Okay, there was nothing. You could say there. If I remove all the objects from the universe, I say there's nothing, and we still haven't invented or created something. And so you would not say, no, it's the absence of things because you haven't defined thing yet. All we have is nothing so far. Okay, so you have to define nothing without alluding to things. So no, nothing is not no thing. Okay, identity itself is a thing. Oh, identity! I thought identity was a concept. Okay, I think I can think about it. Okay, whatever he's thinking. Yeah, maybe nothing. It occupies a place inside my head. Identity occupies a space. You must have a very, very small space. Okay. Between his ears. Hence, it is not really nothing. Okay, saying it's not nothing because he can think about it. Okay, so let's see if we can make sense of what this poor fellow is saying. He's saying nothing is not something. Okay, which is not true. That's not what nothing is. You know, and then he says anything you can think about. That's essentially what he's saying. He can think about it, so that's a thing. No, not in science, not in physics. You can think about motion, and motion is not a thing. Okay? And he says it occupies space. Okay? These are the things he talks about. But yeah, you cannot occupy space like a fish occupies the ocean. You know, a fish occupies an ocean, meaning he displaces water. Okay? You cannot displace space because space is nothing. Okay? And so there we have the definition of nothing, the scientific one, that which has no shape. So if an object, a thing, something is that which has shape, nothing is that which doesn't. It was so simple. And no one has ever defined the word nothing or something for that matter to this day in mathematical physics. So these words are very important because they form the foundations of physics. You need to have objects and whatever's covering them, whatever's, providing background, contrast, that's what we call nothing, okay? And fellow continues, he says, wave is not a verb. Okay, we got to teach him the language, I guess. He says, water is waving. Yeah, water is waving. That's what in ordinary speech is called a wave, noun, right? Quotation. Only in ordinary speech is it a noun. Water is waving is referring to the entire action itself that water is experiencing. To just say there is a wave is to say that it is in fact that something is waving. Yeah, what is waving is called water, not a wave. Wave doesn't wave, it's water that waves. Okay? To just say, to affirm that X is occurring is not the same as just saying X. Yeah, water is X and water is waving is what in ordinary speech we call a wave. Noun. Okay, that's what's happening here. In one case, you are referring to the presence of X inside of a situation, and in the other one, you are just saying X. Your argument does not really make sense. Yeah, I guess, what was it? He's got a very tiny space where he's thinking of all these things. Since it is a false equivocation fallacy. Okay, well, let's straighten him out. These are waves. Well, the top one is a wave. It's known as an electromagnetic wave. And no, it's not a wave because what is it that is waving? Okay, that's the question. And so you need to determine, what it is, what physical object is waving. And what they have there is vectors. See those arrows? Those are vectors. And a vector is a quantity that has direction. That's essentially what a vector is. And so we have numbers there that are moving, and they call that a wave, an electromagnetic wave. No such monster in physics. There is no physical object called wave. What's waving here are the vectors, and those are not things either. So yeah, the word wave is used very irrationally in mathematical physics. On the other hand, you can see what the wave was all these years. It's a rope. It's got the same shape, more or less, right? And it's not moving from A to B like the one on top. It's twirling in situ. Okay, it's a torsion of that rope, and that's what we call light. Okay, so yeah, we talk about objects. We do not talk about concepts. Concepts don't wave, and wave is a concept. It's a verb. Verbs are all concepts, and dynamic concepts, most of them. And so you have a wave. You can't say the wave waved. It's like saying the run runned. No, the boy ran or whatever. is running or whatever. But you cannot say that the run, and that's what you're saying when you waved, when you're waved. Okay, Faust continues. He's insistent. He says, you also fail to show that position is a dynamic concept. We talked about the other day that position is the site actually occupied by an object in physics, in real physics, right? The object occupies that same volume. We call that position. So position is a worthless word in physics. We don't use it for anything at all. In mathematics, in the religion of mathematics, they have a different notion of what position is, and it's motion. It's the same exact word as motion. What they do, they talk about position. They say how to get there, how to get to that point, how to get to that location, how to get to that position. And so they put it in two numbers. They put A and B or X, Y, and they say X is 5 meters, whatever, and B is, Y is 10 meters. So you go 5 meters to the east, 10 meters north, and you get to the treasure chest. And so the position of the treasure chest is not where it's located, because mathematical physics is not interested at all in that kind of concept, in static concepts such as the position. That's where the treasure chest is. No, they're interested in how to get there, because mathematics is only dynamic. It only has dynamic concepts. There's not a single static concept in all of mathematics, and especially mathematics, because we're talking about numbers as applied to an understanding of the world, of the physical world. And so he says that I failed to show that position is a dynamic concept, since it is not referring to the entire process of going to a certain place. That's what he thinks. I mean, I don't know what monastery he studied at, but certainly he doesn't know the basics, because he should have just looked it up, like I'm going to show in a second here, and he would have killed his ignorance. But the result of doing that, no, it's not the result. Its position is how to get there, exactly like I said. Using your universal movie, the position would only consider the exact frame of which you arrived at the objective. That's not true, and it does not care about the process itself, etc., etc. Okay, and there you can see at the bottom, yeah, that's exactly what it is. If you look up position in any math book, it's the AB or XY or whatever letters they use as variables, and it's how to get there. That's what math is interested in. And so here, let's show this fellow what he should have looked up. Okay, so he would have killed his ignorance. This is how position is defined, okay, officially by the mathematical world, okay, mathematics, okay. Position or position vector. Oh, vector, what could that be? A Euclidean vector that represents a point P in space. It represents a point P, but what is P? Its length represents the distance in relation to an arbitrary reference origin 0 or O. Its direction represents the angular orientation with respect to given reference axis. What do you mean direction? I thought we were already there. I thought position was where I'm standing, not the direction. Direction of what? It says usually denoted X, R, or S. It corresponds to the straight line segment from what? 0 or O to P. Okay? It's a straight line segment. What is a line? Line is an itinerary in the religion of mathematics. Okay? Especially in geometry. The first religion that we created, where we tried to unify math with physics. And yeah, it is a religion because line is not a stick. Line is a bunch of positions, meaning a bunch of points, as they call them, locations actually. And the thing that's doing the motion, going from location to location, is whatever the object is, and so it's going from O to P or 0 to P. Okay. And so what is a vector? Because if a position is a vector of some kind, vector is a geometric object. Object? I don't think so. You mean like, is it a figure? Is that what it is? That has magnitude or length and direction. Okay, so vector has magnitude. It's a number. Okay, it's got direction. If it's got direction, it's not standing still. Vector is something in motion. Euclidean vector is frequently represented by what? A directed line segment, or graphically as an arrow. Why would they put an arrow for a position? Connecting an initial point A with a terminal point B, denoted by A, B with arrow on top. A vector is what is needed to what? Carry. Carry is a verb. The point A to the point B. We're going from, the reference point, which we'll call O or 0 or whatever. We're going along the x-axis, or A if you want, and then we're moving along the y-axis to point P or whatever final point is. So we're moving, okay? The Latin word for vector means what? Carrier. Carrier is a verb, okay? There's motion. It was first used in the 18th century. Astronomers investigating planetary what? Revolution. Revolution is motion around the sun. Okay? Hopefully you learned something, but some of these people, they run away and they don't come back. But who knows? Position is a vector. Vector is motion. We're done. Okay? Vector position is how to get there. It's not where you're standing at the end of your trip. Okay? In the religion of math. In physics, it is the same volume as the object. We have no use for position. We only have use for location. That's the word we need to define. Okay, and here we have someone who can teach this fellow something. Listen carefully. Here goes, okay? 1, 2, 3. Uh-oh, didn't work. What happened?
Flight 209 are clear for vector 324.
We have clearance, Clarence. Roger, roger. What's our vector, Victor?
Flight 209 are clear for vector 324.
We have clearance, Clarence. Roger, roger. What's our vector, Victor?
Okay, so what's your vector, Victor? Yeah, that's what position is. It's a vector, okay? Okay, here we have the fellow says, numbers do have empirical basis from reality, and he goes in there, I don't know what he's talking about. So I'll just say that a number is these are definitions of the word number, and I put some references there. Number is a mathematical object. No, it's not. There's no such thing as objects in math. Used to count. Okay, yeah, number is what is used to count. And there you see in the second one there, a number is an arithmetic value. Number is an arithmetic value used for what? Representing the quantity. What's a quantity? It's the same thing as a number. It's the same thing as a value, etc. So they just go around in circles. But I think the bottom line is that number is what is used to count. We say the number is turning the verb to count into a noun. That's what they've done. So let's show this fellow what a number is so that he doesn't embarrass himself anymore. And here it is, okay? Number, a symbol that represents the verb to count. That's what a number is. That's what it's always been, and mathematicians never discovered that. In other words, it's how many times you waved your finger or your hand. Hand is that thing there, just in case this fellow doesn't know what a hand is. Finger is that little thing that's moving, okay, just in case. Anyways, it's how many times you waved your finger when you counted. That's what a number is, okay? And here we have good old Eine, and what did he come up with? Well, we had the rectilinear number line, not a straight number line, so rectilinear one, and you can put those numbers in any order that you want. Numbers have no order. It doesn't go 1, 2, 3, 4, 5 in that order. No, it doesn't. Not in physics. You can put the number 5 on top of your head, the number 1 at the floor, the number 9 to the sides. You can do whatever with numbers because they have no location in space, okay? But what they do, they put all these number lines in a row, right? And they say, and they put an arrow at the end. They say, look, they're all going in that direction. No, numbers don't go in any direction, okay? And then we have good old Annie. What he did was he curved the number line. He warped it. He says, hey, that's what prevents the Earth from flying out of the solar system. We have this curved number line, okay? And that's why, Eine's religion, the one he proposed his suggestion of how this universe works, that gravity is the warping of time, it boggles the mind. That was his physical interpretation. Okay, here we have other people who joined in, more or less, with some questions. Paul says, I've heard a couple of definitions that aren't circular. Good. Point is that which has no part. That was Euclid, right? Go to Euclid at the bottom. Line has no width. Okay? Okay, those are Euclid's most basic definitions. Yeah, exactly. At first, the definitions of point and line looked like riddles to me, and took me many years to intuit their meaning. Good, I'm glad you figured it out, okay? The two negative definitions are truly masterful. Oh, they are? And in my experience, their riddle-like form is designed to teach an open intuition. No, when you have negative definitions, those are not definitions at all. Just like this fellow said, nothing is that which is not something, or something along those lines. No, that's not what nothing is. What these fellows are saying, and those people who like to define in the negative, they say, can you define what a dog is? Yeah. What is a dog? Well, it's not a cat. Oh, okay. And, but is it like a hog or like a lion? No, it's not a lion either. And it's not a tree, and it's not a house, it's not a rock. And they go through all these knots. Not. Who's there? We got a problem. We got a problem because you can't define words in the negative, because antonyms are not definitions. Antonyms are simply same thing as synonyms. They are circular definitions, okay? Because then you got to go to the the other guy, and say, okay, if nothing is the absence of something, what is something? Well, it's the absence of nothing. And you go around in circles. So yeah, these people never learn how to define words, and they think of themselves as philosophers or linguists, or who knows what they have going through their tiny brains. And as fellow continues, he says the following. He says, I start from coherent semantics. Okay, good. That won't fall into the trap of infinite regression. Good. We should avoid that, okay? That requires holistic polysemantics, open to various coherent interpretations. What is a polysemantic? Okay, let's see. Let's put that up there. That's polysemantic. It's when a symbol, word, or phrase means many different things. So what this fellow is doing, he's doing double talk. He's saying you can have this this word that means many things at the same time to confuse you completely. Yeah, we don't do that in science. In physics, we have to define the word in the opposite direction. It has to be not polysemantic. We do just one definition, and it's got to be crisp, very crisp, so we know exactly what the word means. Okay? And so, yeah, this fellow says, just goes on and on with holistic formal language can be given various interpretations from various participatory perspectives, and then the interpretations, communicative definitions. Holistic perspectives work by their what? Mereological nature. Mereology is religion. It's known as religion. Anyone who introduces mereology is introducing religion into science. And it's very common to do that among the mathematicians. What is mereology? Well, here it is. Here's an example. An object is a table. You point to it and say table, and the Klingon knows what you mean by the word table. We're done. It's a photograph. Okay. On the other hand, these people do mereology, and that means that you're going to look at what a thing is made of, or you have these temporal parts. Like you don't see the table all in one go. You see it from left to right, or right to left, or north to south, or who knows what, right? And so it's got all these parts. It's got the legs, it's got the the board on top, and so on. And so they say, look, it's a table is many parts. Or you see it in parts. You see it from left to right, piece by piece, because you can't see it in one go, or whatever. They come up with all this nonsense. It's called mereology. And that's what this fellow proposes. He says, no, we can do it with mereology. And no, mereology, we say that it belongs to idiots. What is an idiot? It's a person who has big ideas, okay? So we have little ideas, those are ideas, and then idiots, those are big ideas. And these people are idiots, yeah. So, what can we say? These people never took a single course in science and physics in their lives. And so I don't even know what they're doing, looking, for sites that deal with physics, or language for that matter, that applies to science. These people should be at the monastery, counting the buttons on the priest's frock. Okay, Paul says, aren't your ropes also four-letter words, too, according to your own definition of what is forbidden in physics? Well, four-letter word, we mean a concept that is used as an object. And a rope is not a concept. Rope is a thing. If you want to prove it to yourself, go to the hardware store, ask for a 2-strand rope, and they'll give you something in your hand that you can take with you. Okay? You can't take a wave, like this fellow suggested, because what would they give you? An electromagnetic wave. I want an electromagnetic wave with lots of vectors. Yeah, sure. You won't find that at the hardware store. Okay? But a rope is a thing, so we can use it. It's not a four-letter word, okay? Even though it is. Okay, geometry was the first religion that attempted to unify math with physics, and that's where they bombed out, because they have all these words such as point and line, right, that they remain undefined to this day. And the reason is very clear. Point is not point. Point is location, and they specify it with a dot, and the dot belongs to physics. The location belongs to concepts, right? And then they're going to move it, that point, they're going to move it along rectilinearly, and they're going to call that a line. In other words, we're talking about a motion of something, okay, motion of a dot in this case. And no, that's not a line. A line is a stick in physics. That's what a line is. It's two-dimensional. That's what a line is. Now, the one in math, they, again, try to confuse you and say, look, we're going to put a stick there, a two-dimensional stick, but it represents. Don't take it literally, it just represents an itinerary. What is the itinerary? Many locations. What is a location? A point. What is a point? What do you call it? A position, a pair of coordinates or number lines, I guess, that take you there, and so on down the line. So geometry is a religion. It's a religion because it's attempting to unify what is ununifiable. You cannot unify math with physics, and this was our first attempt to do math phys. Okay? It was the first attempt to blend measurement, dynamic description with science explanation also. What is a point? Geometric object, okay? The real one, but not in geometry. In geometry, it's not a figure because it's zero-dimensional. Why? Because they're talking about how to get there. They're talking about position. And in string theory, they have this string. No, it's not a string. They call it a string. It's very, very misleading. They're not even talking about a line. They're talking about a sequence of locations, and the location is zero-dimensional and somehow constructs a one-dimensional line. How they do that, I don't know. That's magic. Okay? And so, no, the string theory is not a thing with a string. Okay? It's just a bunch of positions, points, whatever you want to call it. It's a concept. And again, position, how to get there, which is the same thing as motion. And position is what they're going to use as a brick, as a building block, right? They're going to build their geometric figures, starting with Euclid and probably people who came before them. They're going to build their cubes with positions, with these locations, with what we call location. And they're going to unify all these little dots, and they're going to say, now you have a cube because it's made of locations. That's more or less where geometry started off on the wrong foot. At least they never separated the concept from the object. That's where the crime was committed. Okay, and here we just have a little summary. Math never used objects. Math has no use for object. That's why when they say it's a mathematical object, it's ridiculous. We don't even know what they're talking about. What do you mean a mathematical object? What's an object, let alone a mathematical one? Math is a dynamic language, only deals with dynamic concepts, geometry especially, right? Physics, scientific discipline. It has nothing to do with the religion of geometry, okay? Math never defined a thing, pun intended, okay? Yeah, never defined a thing. And that's why, in math phys, you don't find things. You find concepts such as, space-time, and you find dark matter, which is invisible, and I don't even know if it has shape. They don't even talk about that. They just say, look, it's invisible, untouchable, it just has mass. And then they have the, what is it called? The wave packet, right? What is a wave packet? Is that a thing? Well, no, it's because light behaves sometimes as a wave, sometimes as a particle, and so we call it a wave packet. And so they have all these concepts and or a tachyon, it's a particle that comes from the past or from the future, or who knows from where it comes. And so they have these concepts: energy, field, force. What is that? Time. What are those words? What do they have to do with science? Okay. And so again, they use all these words. They use them as physical objects. That's where the crime is committed. That's the 4-letter words that we're talking about. And so yeah, they end up with irrational physical interpretations. And that's how they ended up with black holes, dark matter, and all this nonsense that you see out there today. All this poppycock. Okay? Let me remove this one and get with the last fellow here. Here he is. And he says, my question about heat death of the universe he was talking about was not answered properly. Okay, sorry. I was just wondering if, since suns die, all the suns will eventually die and universe will become lifeless and suns will remain forever, or whether suns will remain forever. And the way I look at it, at least, is that there's a single closed loop thread in all the universe that makes up all the atoms and the ropes that connect them. The ropes are going to convey the signal we call light or electromagnetism or whatever you want to call it. And all these atoms form, things such as big objects such as the Earth, you, me, and stars, suns, etc. Right? Okay, so they form all this. Now, he's asking whether the suns, the stars, will disappear. And my answer is, I would say no. I mean, I don't know what's going to happen in the future. If I would have to guess, I don't think the whole thread can disentangle itself. The universe is perpetual, has been perpetual, will be perpetual. And what I really mean by that is there will be no changes. There will be suns destroyed, blown up in some part of the universe, a nova, supernova, or whatever. And in other parts of the universe, you have stars that are being born. So you have this nursery where stars are built from debris from other explosions, and you have the explosions. The explosion is the death of a star, and the nursery is the birth of a star. And I think that process will continue forever. It never had a beginning, never had an end. Which means, like I said last time, and this one should keep you up awake at nights, there never was a first human in the universe. There never was a first human in the universe. If you went back a million years, a billion years, you would find a human somewhere in another planet in the universe. And if that person goes back a billion years, you would find another human in another planet somewhere in the universe, and so on down the line, at infinitum.